All right, so we're going to talk a little bit about this thing called buffer overflows. And we just mentioned a little bit earlier about the simple concept of having just some basic understanding of what a buffer overflow does. Specifically, being able to fill up a cup as much as it can possibly go, and then be able to watch that thing spill all over the ground. Be an interesting science project to have, but we're not going to do that here because it would just get a little bit too messy. But for our purposes here, we're going to talk about the buffer overflow. We'll get into understanding what the heap is, and I'm not talking about the car that we had in the past. I'm talking about some of the specifics. Like that. I'm talking about some of the things where the heap and the stack. So for our purposes right here, 314 in the book. Thank you. 314. We'll talk about the heap and the stack. All right, so buffer overflows here. Usually you see this in web servers, but could be in any web server as well as application or a program. And we're gonna write a program in C. And fear not, if you've never written anything in C, then we'll go ahead and baptize you with that today and get that going. So the stack based and a heap based. What's the difference between the two? Anybody got an easy way to remember this? Huh? Got an easy way to remember it?
I didn't get a question.
Stack or heap based buffer overflows. What's the easy way to remember?
Well, so we should first think about what the difference is between a heap and a stack.
Okay.
What happens with a stack? So a stack occurs, each command is pushed onto the stack, and the first in is the first out, okay, for that activity. If you only allocate, for example, 10 bytes, and you attempt to put an 11th byte onto top of the stack, what's going to happen to the very first thing that went into the stack? Well, will anything happen?
The one block from your group.
Okay, so now you've essentially, you've overloaded, you've prevented it from having the proper numbers, right?
Okay.
All right, so that's the first thing. So understanding what the stack is versus the heap. You did a project on a heap, didn't you, Ben?
I did, and being able to, just like Jason said, usually you push to the stack and you pop from the heap. So understanding those would be an easy way for us to go through and see how we can either corrupt any of the data or maybe try to overwrite memory. If it, like we just talked about, in our SQL injection the other day, we had 10 characters. If we pass an 11th character, what's the program going to do to it? Is it going to barf? Or is it going to maybe catch the exception somehow? In our particular case here, we're going to go through and play a little bit with a C program so we can understand a little bit more about what the heap and some of these pointers that will be associated with it specifically. So when we get into the stack, you push to the stack buffer and you pop from the stack heap. That's an easy way to remember it. So our particular opportunity here, the null operations or NOPs, usually you may hear something like a NOP sled, where you'll push to the stack and actually slide to a particular place in memory. And then based off of that particular place in memory, you may be able to catch the exception. And that's really what we're looking to do here. We're looking to be able to, how are we going to be able to catch the exception in order to point it to somewhere that we know is a legitimate place that we can fall when this thing overflows. So you force the thing into submission, you get it to basically break, and then you catch it. And in Windows now, or in many of the .NET languages, they have a try and a catch. You may have seen that, the try catch. And Java has adopted it, so .NET, C#, Java now all have a try and catch that you see. And what we usually will try to do is, if you try to input something, you try to catch the exception. And if you're able to catch the exception, then you can error out gracefully. But if you don't have that, how are you going to be able to do it? Well, what do we need to know? You need to know how we can actually go in and overwhelm the system, whether it's using the stack or the heap. Remember, we push to the stack, we pop from the heap. In our particular case here, we're going to go in and do a simple buffer overflow in C. So let's go through and do that real quick. In the book?
Yeah.
Thank you. So Microsoft, yeah, here it is right here, the heap and stack, thank you. Heap's dynamic storage that does not have sequential constraints, and then the stack refers to a smaller pool of free. And it gets a little bit confusing, but here on 268, usually you push, what it says here, last item is push to the stack, and you pop, meaning you remove the item from it. And our particular purposes here, that's what we're looking to do. We're looking to basically manipulate these stack pointers and be able to see if we can get it to crash into something that we want it to do. Now, it's interesting to think about this. Microsoft, you may have seen this depth control now be put into play, this data execution prevention. Anybody seen that? So Google in China had a problem. It was about 5 years ago, I think, called Operation Aurora, where Google said, hey, Chinese, we're certain that you guys just hacked our Chrome browser. But what that was, a manipulation on the heap within Chrome to be able to overwhelm the heap. And by doing that, it was able to get it to crash into a place within memory on the computers that were using Chrome. And then you can inject different tools or code into memory after you do that. So let's go through and do an example here, because I think that this will probably make more sense. And then we can come back and take a look at this. So we'll log back into our Linux box here. And what we're going to do is just open up LeafPad. What I'll ask you to do is open up LeafPad. So go to New and then open up LeafPad. And now what we're going to do is just go through and start slinging some code. So you don't necessarily need to be an expert. You just got to kind of understand the way that these happen. Again, they go in, they try to check for data values and be able to manipulate memory in any way we want. So up top here, just like with our shell script, we're going to go ahead and declare that, hey, we're going to use C as our programming language, and the first thing we're going to do is start to include other libraries. So no, this isn't the studio here. What do you think this is right here? It's telling.
Standard input output.
That's it. Standard input output, and this is just a native thing that's inside of the compilers for adding libraries to any C as we go through. So let's put that in, and then we'll go to void space main, and then it has little brackets on it. And let's go through and do it. I'll give you guys a couple minutes to type this up before we actually compile it. All right, well, I'll come around here in a second. All right, so we got the buffer.c. We're going to just go in and we'll save it here. So in my distro, what I can do is I can just go save as, and I have it up here. Save it as buffer.c and pop it to the desktop. All right. So now that we have this, we should be able to go ahead and compile it. Let's just open up a command prompt here. Make sure that you're in your PWD pop chip onto the desktop here. So CD to the desktop if you have to. And I can see that buffer.c is right there. All right, so now what I want to do is I just want to type in GCC and see if there's something available. So I have GCC running on my system, and what that is it's a compiler, a C compiler, that we're going to go ahead and just compile this with. So we're going to go GCC, and we're going to say buffer.c, and then whatever we want to call the file. So I want to do minus lowercase o, okay, and then whatever we want to call the file. In my case, I'm just going to call it, how about overflow? I could call it buffer, but I'm just going to call it overflow, okay? So I get back some issues, but now what I should see on my desktop is if I just do an ls, I should see overflow. And see how it's green now? Pretty cool, right? All right, so, okay, well, let me come around and check it out. Hold on. Yeah, so just like before, we have to go through and troubleshoot the issues that we had with the code. So you got to go squash the bugs with the code. But in order to run it, as long as it's green, now means it's executable, we do a dot / and then overflow in my case. All right, so now it's saying the address of the name is 137.285.640. Address of the command is, okay, I probably got a problem with that, D%. The difference between the two is 16. Okay, so enter my name. Okay, let me just enter my name, Ben. Okay, there we go. It says hello, Ben. Perfect. All right, so that's the desired output for me in my case. When really, what I want to do is maybe see what happens if I do what happens if I give it 17 characters. So let's just say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, 11, 12, 13, 14, 15. And then if I go something like cat, Etsy, PSSWD, what did that just do for me right there? What is that? Oh, how did that happen? Let's try it again. Oh, you found the error? Okay. Well, let's do it again, and I'll come by here in a second. So let me just get through this demo here. If I was to go through and say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and then I just did something like this, what do you think is going to happen in that particular case? So what did I do here? What did I do wrong? Well, I only gave it 14 characters there. What if I was to do now I give it the proper characters? Oh yeah. So what do I got going on now? Oh yeah. So now if I had something, let's just say right here on the desktop, remember from before, I could do virus.sh. Hey, that's the Big Benny virus that we created earlier. Thank you for clicking me. Now I could probably just take a look at the desktop and see whether or not that file was actually deleted. But I essentially have overflowed the buffer in a way that now I can have command line access. So here's where I put in my persistence, right? I would go in, maybe, create a cron job right here, or maybe put netcat, upload netcat, make sure FTP is running, those types of things on here. So check that out, and I'm gonna come around and check out, make sure you guys got this running, because I think this is important.